Hi, and welcome to our lesson for today. As we continue with linear inequalities that we have started with a week ago, we want to make progress on what we have learned. Up to this point, we have learned linear inequalities in general, what a linear inequality is, and we have seen also how to solve linear inequalities and all that. But you will see and agree with me that what we have done so far and what we could do solve up to this point is inequalities that are involving values that are not absolute. That is to say, we would say x is less than or equal to, or maybe we say is greater than or equal to a value. And in that case, the possible solution for x is any value that that meets that inequality to infinity. That is to say, for example, if we look at a situation like this one, if we say we are looking at x less than 3, so any number that's less than 3 is a possible solution to, or a possible value of x. So it has no end. That is to say, from 2.999999 to negative infinity, all those values are possible values for x. So, and that's what we have looked at in our previous class. Right. But today we want to look at how to solve linear inequalities that involves absolute values. So absolute value, like we have here, we have x inside those straight brackets. Okay, that is the absolute sign. Okay, when you put something between those straight vertical brackets, then we call that absolute. All right, that's to say that this particular or the solution to that particular variable, the possible values of x in this case are absolute. They start somewhere and end somewhere. We know that absolutely any value that or in other words, let me just rephrase it. We are actually saying the value of x is absolutely from a particular number up to a particular number. Any number that lies in between those two definite points is a possible solution or a possible value of x. That's basically what we are looking at. That's why we call it absolute value. Absolute value. All right. Now, to solve a problem that involves absolute value, inequality problems that involves absolute value, in that case, we have to consider both the positive and the negative. So the absolute value here, actually, what it means is that we are looking at the number, the digit itself, not minding the sign. All right. If, for example, we have negative 3, the absolute value of that negative 3 is just 3. All right. Whether it's positive or negative, we don't care about the sign. All we care about is the value itself, the number, the digit itself. All right. So that's the absolute value. Now, if we are saying that the absolute value of x is less than, in this case, 2. All right. We are saying that the absolute value, the figure, the number itself, the value of x without minding the sign is any number that's less than 2. All right, any number that's less than 2 is the absolute value of x, or rather the value of x, the absolute value of x is actually less than 2. All right, that's basically what we do. And if we take that one to basically what we are saying, and if we take that one to our number line, you will discover that, but before the number line, if we are to now solve that, or to solve that, we have to, in this case, take into account both the negative. That is, we have the positive 2 and the negative 2. to say that actually the value of x is any number that lies between -2 and a +2. So we start from -2 up to +2. Any number that lies in between there is a possible solution, a possible value of x, and that's how we indicate it on our number line, where we indicate where we are starting from, -2 there. That's where our line starts from, and it ends at +2. And as you see that those dots that marks the end and the beginning and the end of our line are empty. So empty, which means that those two values, those starting points, are also possible values, and that is what we use when we are talking about less than. All right, I'm sure you might have learned that one up there if you read everything. So but what we are saying is that when the point where we are starting or where we are ending is also a possible solution, then we use an empty dot. If that is not included, sorry, it's the other way around, sorry, I'm sorry about this. So if that number is not included, that, like in this case, -2 and the +2, they are not possible solutions, because we are saying the solution must be less than -2. I mean, yeah, must be greater than -2 and must be less than +2. So 2 itself is not less than 2. So -2 is not greater than -2. So that's why we are saying those two are not part of the solutions, are not part of the possible values. So that's why we use an empty dot. That means they are not included. So, but if all right, what we are saying is that if we use empty dots, it simply means that those numbers where we are starting or where we are ending, they are not possible solution to the values, or they are not part of the solutions or the values of x. All right. So but if we were using the less than or equal to, okay, then in that case we use a full dot, which means that that particular point where we are starting or ending is also included. Right, let us look at an example here. We have an example that says solve for x if the absolute value of 4x minus 4x plus 10 is greater than or equal to 2. All right, we are saying the absolute value of that is actually greater than or equal to 2. So to solve this inequality, we write both positive and negative values of 2 on each side of the inequality and leave it in the middle. That is the inequality. We leave the inequality in the middle while we are placing the values, I mean the 2, both the positive and negative, on both sides. Okay, now in this case, now we will have, if we remove but take note, the moment we introduce the negative part, then the absolute sign disappears. Those vertical brackets disappear. So now we will have -2 greater than or equal to minus 4x plus 10 greater than or equal to 2. All right, so the same greater than that we found there, greater than or equal to sign that we find there, that inequality, we put it on both sides so that we can also have -2 on the negative side, okay, on the left hand side. Right, if we do that, now to find the value of x, you'll have to take away that 10 in the middle. Okay, that 10 in the middle, we take it away from there. You know from our last year's mathematics how to make subject of how to make a particular variable to be the subject of the formula. So everything else that doesn't contain that particular value, that particular variable that you want to make subject, you take it to the other side, okay, to the right hand side of the equation, so that the terms that contains the variable that you want to make subject remains on the left hand side all alone. All right, but now we could have used that, all right, in this case also. We could say take 10 to the right hand side of the equation, but now in this case we have two sides. Okay, you have two inequalities. You have the greater than or equal to, they are now 2. Remember, these are standing in for equal. So if we were dealing with equations, we were going to have two equal signs in one equation. So all right, but now we are dealing with inequalities, so we don't use equal signs, we use the inequality signs. Okay, like in this case we are using greater than or less than. What am I talking about? Greater than or equal to. All right, so that's what we are using now. So that means now, since you have three sides actually, you have the left hand side, you have the middle side, and you have the right hand side, okay, of those two uh, 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 um, inequalities. All right, so now what we have to do is to take that 10 to both sides. Okay, you can't just take it to the right hand side. So you have to take it to both sides. Take it to the right hand side and also to the left hand side. That's why we will end up with negative 2 minus 10. So remember, when you are taking that 10 to the other side, it must change the sign. Okay, negative 2 minus 10 greater than or equal to negative 4x plus 10. That 10 is still there. You remember what I tried to explain the other year, last year now, that is to say, you don't just take the thing to the other side, you actually subtract the opposite of that term from all the sides. All right, so that 10 cancels the other 10. So you have a positive 10 and then minus 10 that cancels that. That's actually what happens, instead of just us just saying take it to the other side. So you are basically subtracting 10 from all the sides. All right, so you subtract 10 from the left hand side, subtract 10 from the center side or middle side, and subtract 10 also from the right hand side. That is basically what you are doing. And then on the left hand side, now we are going to have 12, negative 12 greater than or equal to minus 4x greater than or equal to negative 8. So if we do the math, all right, and then to find the value of x now, you have to take away that negative 4. You divide by negative 4 on all the sides. So now it's not only both sides, it's now all sides, because we have three sides now. Right, negative 12 divided by negative 14 by negative 4 gives us 3. And then negative 4x divided by negative 4 gives us 1x. Negative 8 divided by negative 4 gives us negative 2. But take note of the fact that now the sign has changed. It was a greater than or equal to, now has become a less than or equal to. Why? Because we are dividing with a negative. So take note of that. Anytime you are dividing or multiplying with a negative, the inequality sign changes, flips to face the other side. So that's basically how you solve linear inequalities that involves absolute values. So now in this case, the values of x, the possible solutions of x, is any number that is greater than 3 but less than 2. All right, so I see there is a something is not right, because you can't have a number that's greater than 3 but less than 2. So it was the issue of signs. So something needed to change there, so that the 3 becomes negative. It's supposed to be negative. So yeah, but that's basically how to do it. The method is right. It's only that the choice of signs was not properly thought of. All right, but otherwise, so that would give us the correct or possible solutions now to the value of x. So any number between those two limits or those absolute values could be a possible solution. So that's basically it. Please, I want you to, as we now conclude our lesson for today, I want you to work through these exercises from 1 all the way to 6. Work through that, solve for x, and see if you make meaning out of all these things and get them right. Otherwise, thank you very much. That marks the end of our class today. Until next time, stay well and God bless you.